Ladies and gentlemen, welcome back again. It's James from Zygal Studios. So, last lesson we talked about variables. And first we're going to go over the homework assignment. This is one solution to this problem. So the homework was to make a program that has each one of the arithmetic operations and uses all four basic types for these operations. So you had to go through each of these four basic types. You had to do the operations and then print them out using printf. Here is one solution. I have the variables initialized up here. And then all the print and operations are done here. You may stop the video now if you'd like to go over the solution and see if you can get it. Here's proof that it works. There you are. Alright, since that was a pretty easy lesson, let's get into today's lesson. So today's lesson is going to be looping. Okay, we have a fresh, new C file for our lesson today. Okay, so loops. So variables are probably the most quintessential foundations of C. Now we're going to talk about loops. So loops are, well, the next step. All right, so imagine you have a few rows of stars here in a triangle formation. So let's say I want to get to the second row and the third row quickly. So there is one way that you could do this. So you could, for example, do something like this. You could do something like this. So let's say I is 1, J is 2, K is 3, and you could just go down the line like this saying, all right, well, you know, each one of those represents a number. Well, the problem with this is it's kind of disgusting. And imagine if you need to do 1,000 of these. So let's say eventually you get down to the bottom and you have 1,000 stars. You can't really do that by hand. You could, and I'm not challenging you to because it's mundane, but you could. But there's got to be a better way to do it, and of course there is, and those are called loops. So essentially, what loops are a way to develop concise programs containing repetitive processes that otherwise would require thousands, if not millions, of assignment statements. So C programming traditionally has 3 statements for looping. First loop type is called the for loop. So this is probably the most popular referred to in pop culture, the for loop. We'll get into that in a second. There's the while loop. Then there's also the do statement. So the do statement refers to something a little bizarre, and I'll get into the concept when we start talking about while loops. But let's start with the for loop. Like I said, so let's start simple. Let's say I have an int here that starts at 0. Let's say I want to count this int up to 1,000. Seems reasonable. This is the whole point of loops. All right, so we have a for loop. So this is the general kind of functionality of a for loop, or the general look. You have parameters inside this loop, and you have what you want each iteration to do. So the idea of a for loop is that you give it counting parameters inside of these parentheses. So this is what you want the for loop to do counting-wise, how you want it to iterate and increment, or decrement for that matter. And inside the brackets is what you want it to do on each incrementation. So remember how I said you could count from, so 1, 2, 3, 4. So for a for loop, let's say we want to count to 4. Let's say we want to count I up to 4. All right? So the first argument is the variable you want to count with. So this is very useful. This is the C99 standard. We're going to be following that. You're allowed to declare variables inside of a for loop. Older variants, you cannot do that. So we have our variable initialized at 0. This is very important. You have to initialize this at 0, otherwise there's undefined behavior as to what that value will be, as I talked about in the second lesson last time. Okay, the second is what we want to constrain the counter to. So for loop just means it's going to count I. Let me rename this. For loop just means it's going to count j up to whatever you specify, and this condition, the second condition, separated by a semicolon, mind you, is going to be what it's going to count to. Something to keep a note here, if you're starting at 0, it's going to be -1 of what you actually want to count to. So if we want to count to 4, actually, no, excuse me, it's going to be +1. Oh my goodness. It's going to be +1 of what you want to go to. So let's say we want to get to 4. And in order to get to 4, if we start at 0, we have to go from 0 to 1, we have to go from 1 to 2, we have to go from 2 to 3, and then we have to go from 3 to 4. Okay? So each iteration, it will increment when it reaches 4 again. So 5, and then plus I. Okay? So here's how it works. The first time through, j is 0, okay? For Pete's sake, James, come on. For the first time through, j is 0, okay? It's going to compare, is j less than 5? Yes, it is. So if j is less than 5, we are going to count up j by 1. So the first time through, when j is 0, it will be at 1. At this point, we want to do j, okay? And then what we're going to do is we want to increment I, so we can do this, plus I. Or we could start, yeah, we'll just do that. This will be better for the sake of things here. Okay, so if we increment I, and something kind of bizarre will happen here. I'll show you what that is in a minute. But okay, so we increment I, and then we want to print I. Okay, so this program will go through each time, increment the variable j, compare it to see if it's less than 5. If it isn't less than 5, it will pop out, or it will continue to increment I and print the value of j and I, until j has officially been greater than 5. So once j hits 6, that's when we pop out of the loop. Okay, so let's compile this right here, and let's see what happens. Okay, no warnings, no errors, we're good to go. Okay. Alright, so maybe I should print a space here, just so we know what the difference of iterations are. Let's recompile. Oh, that's... Man, I am really not on my game today, am I? Alright. So, recompile. Go. Alright, so let's look at this here. So, we wanted to count I to 4, correct? Well, here's the trouble with that. Let's take a backtrack. So if we want to count I to 4, wouldn't it make sense that we just add 1 to I every time the for loop goes through? You would think that would be the case, but not particularly. And this can actually run into a lot of errors for you as you move on. These are called off by 1 errors. So a common thing to do instead would be to use j instead of incrementing I. So setting I equal to j, that's one way to solve this. Or you can just think about how you're structuring the loop. So on the first time through, j sees that j starts at 0, okay? The first time it says, okay, 0 is less than 5, so we will increment j by 1, which is plus j. It will then print the value of j, which is 0, and it then increments I by 1. Now, it doesn't increment this until the loop iteration has finished. So this is important to note. The for loop will only increment the second time around. So once the loop scope is finished, so in other words, where these brackets are, once the program has exited out of those, j will increment in memory by 1. I, on the other hand, does not. I stays in here for 5 iterations. So this is an important distinction to make as a programmer, because you're going to be using for loops a lot if you continue to program, and you have to know the difference between zero indexing something, starting something at 0, which is actually not exactly what this is, but you really have to understand how for loops execute instructions in order to fully utilize them without, well, causing trouble for yourself, because you could spend hours looking for a bug eventually, and this could be the problem. So let's continue on here. So the second time around, after we hit this bracket here in instructions, the assembler will then go back through into the for loop again. This time, j is incremented by 1. So we print out j. I is incremented. We now print out I. I has gone up by 1 as well. So j is 1, I is 2. Second time around. Get it? It's the third time, but 0 indexed. Third time around. We have plus plus j again. So that means that, well, j went up by 1 from the previous iteration. So j is now 2. We increment I again from 2 to 3. So 2 and 3. J is incremented again. Now we're back in here. J is 3. Is j less than 5? Yes, it is. Okay. Now we're rolling along again. So hopefully this makes sense by now. But the idea is to essentially do this loop until a certain number of parameters are met. But now let's go to the final iteration. So j is 4 after we go through here, okay? And I now increments to 5. Now on the next time around, the for loop says, oh, well, we've incremented j to 5 after we've exited here. J is now 5, and j is not less than 5. J is equal to 5, so we break out of the loop. So this brings up another key point. The break statement will end loop execution immediately once it hits. So, for example, if I recompile this and run it again, it only does one iteration because the break statement was hit. This is exceptionally valuable if you only need to check to a certain index and break out of the loop. We'll get more into that when we start talking about if statements. So the break statement breaks out of the loop whenever the break is hit inside of the for loop. That is one keyword that you should know. Okay, so yeah, we don't want to do that. I don't want to do any searching. Okay, so now that we kind of get the basics of loops, they start at whatever you set them, so they can start at 0, they can start at 1, they can start at 100, they can start at anything. But make sure that you understand what happens before you start using them, because you can end up in a lot of trouble with off by 1 errors. Couple things, key things to remember here. They start at whatever you initialize them at. The logical condition in the second slot of the for loop is going to be the condition at which it checks before it breaks out of the loop, and the third argument there, plus plus j, is an increment by 1. You can increment by however many you want, too. It could be 100, it could be 1,000,000, it could be 2, it doesn't matter. That will be done once the program execution is outside of the scope of the for loop and will go back in again. So it's done when all the instructions for that loop inside of the scope have completed. If you know those 3 things, you'll never run into a problem looping, at least on purpose. Okay, so now that we're talking about this, let's move on to the while loop. So the while loop does exactly the same thing in terms of program execution, besides for one thing. The while statement will stay in the confines of these braces until a logical condition is met. And what do I mean by that? So essentially what that means is you can check to see if variables are greater than each other or less than each other or equal to each other. So let's take a look at this. So let's say we have I, and that's, I don't know, 5. And we have j, which, well, actually, here, let's do this. We have k, and we have l. And let's say l is equal to, I don't know, 3. Okay, so we can say while l is less than k, we want to print out loops with a return character. Okay, so now, here's the real question. What do you think this program is going to do? Because what we're saying is while L is less than K, we print loops. So here's once again a conundrum you can find yourself in very fast if you don't understand loops. So let's try this. Watch what happens. It prints out loops forever because L is not incrementing to become larger than K. Okay? So let's try this again. This time we're going to increment K. So I'm going to steal the code from this loop here and replace this with K and L. And we'll take a look and see how we can do this. So we want to increment L because that's what's less than, right? All right. Interesting, huh? So if L starts at 3, the first time through, it's going to compare to see, is L less than K? Is 3 less than 5? Yes, it is. We print out K. Okay, we add 1 to L. That means that L is now at 4. So that's why we see that on that screen. Next iteration through. Is L less than K? 4 is less than 5. So we print K, we add 1 to L, which is now 5, and yahoo, we are there. The next time it goes around, it will say, is L less than K? No, it is not. It is equal to. So once that happens, that will now go out of the while loop. Now, another thing you can do is exactly like what I showed above with the break statement. So let's say you reach a condition and you want to get out of it immediately without having to go through the rest of the iterations. The break statement works just the same. All right, so now we've kind of gone over the while loop a little bit. Let's tackle one more thing. So there's the difference between less than and then not equal to. So let's do a not equal to for right now. Okay? This is the same as the code above, where we're doing less than and increment by 1. So you can do a number of different operators. You can do let's do this. You can do not equals. You can do equals equals. There needs to be 2 equal signs. That's a note. Okay. Oh my goodness. Okay. Then you can also do and, well, we'll stick with this for now. You can do less than. You can do greater than. You can do less than or equal to. And you can do greater than or equal to. All of these are valid operations while inside of a while loop. Inside the parameters of a while loop. Okay, the final statement is the do statement. So the do statement is generally paired with the while. So do is guaranteed to execute one instruction in front of the while, regardless of what the while loop's conditions are. So even if the while loop is false, so it will still execute that instruction. So let's swap these two. Let's make them equal. So K and L equal to 4. So what the do is going to do for us here, it is going to execute that it will print I print no matter what, regardless of the logical statement. So the do will ensure that whatever's done inside the do statement will happen regardless of the condition of the while. So let's say that we're looking for L not equal to K, and we want to print I print no matter what, regardless, because do will do that. So it'll at least guarantee us one iteration here of the while loop. So this is helpful if you don't want to zero index it, although you can do this with variables, so it doesn't make a lot of sense. So I print no matter what. So even if that while statement is false, it will still do the do operation first. The last thing I'll talk about in terms of loops before I give a homework assignment is the continue statement. So this won't really become... So there is something else called the continue statement. I'm not really going to get into that. I don't really think that that's a important thing right now. That'll become more helpful when we start talking about if statements and switch case statements. I'm going to give a very simple homework assignment. This should take no more than 15 minutes. Write a factorial algorithm of 15 factorial. Okay, you can use any method of loop you'd like. You can use a do while, you can use a for loop, you can use a while loop, whatever you guys want to use, but I want 15 factorial to come back. I want the answer to 15 factorial written using loops. Thanks everybody for stopping by. I really appreciate it. I really hope this series is helping some people out. The next lesson will be next week. We'll go over the homework. And I do have office hours on Twitch. I stream every night. I'll leave that in the description and the outro. Thank you so much for stopping by. And as always, keep those fingers loose. We got a lot more material coming your way. Hey everyone, it's James from Zygal Studios. So thank you for watching my tutorial on how to program in C. There's going to be more videos coming in the future, so if you could hit the subscribe button, I'd really appreciate it. I've wanted this series to take off for a while, so please, if you could, show some support and like and comment on the video if it helped you. If you guys have any suggestions for future videos, please put them in the comments below. Thanks so much, and hope to see you back here again soon.